Hey class, good morning. So today we're going to solve problems with the quadratic equation. So we have this problem, an example problem here, x squared plus 18x plus 4 equals 0. Now it's already in standard form, right? So we have x squared plus 18x plus 4 equals 0. And then we may try to factor it to see if we can get the factors. But we only have a 2 over here, a 4, right? So what are the factors of 4? 1, 2, right? 1, 2 times 2, 1 times 4, 4 times 1. And none of that is going to combine to get to 18. So we can't just do the normal simple factoring. We do need to use the quadratic formula, right? And that quadratic formula is negative b plus or minus b squared minus 4ac over 2a. Okay, and to determine these coefficients a, b, and c, we have to put the equation in standard form. So sometimes, and that means everything's on the left-hand side of the equation, and the right-hand side is equal to 0. And literally what we're looking for is, well, let's start with the a, b, and c a minute. So the a is the right. If we look at the notes that are posted for 11.2, we see that the thing multiplied by the x squared is a. So in this case, a equals 1. B is the next one, right? We put it in descending order. X squared x, the constant, equals 0. And whatever's multiplied by the x squared term is a. Then whatever's multiplied by the x term is b. And sometimes this is 0, right? We could have x squared plus 4. So sometimes b is 0. And sometimes c is also 0. So a equals 1. In this case, a is 1. And b is equal to 18. And c is equal to 4. Now there's a couple things that happen here. So I mentioned to you last time that when a parabola opens upward, the a term is positive. And so I don't know where this is yet, but let's just say we have this parabola. And what we're trying to do is find, right, let's say this is the x-axis, right? This is where y is equal to 0. And we're trying to find these two, what are called roots, or the solutions here, that you can plug in and get y equals 0. So when we solve this quadratic formula, we're getting x equals these two locations where y is equal to 0. And that's why we set it equal to 0, because y is 0, and we're looking for those two roots of the equation. Again, the a term, if it's positive, it opens upward. If it's negative, it opens downward. And then we always have this line of symmetry with a parabola. This isn't part of this particular problem here, but this occurs. X equals, look, we could separate this equation out to say x equals negative b over 2a plus or minus b squared minus 4ac over 2a. Okay, so this line of symmetry occurs here at this first part of the term, negative b over 2a. Is the line of symmetry for a parabola. And then we add some term to get to this one, and then we subtract some value to get to that one. So that's what's going on here. And another thing that goes on here is if this term here, b squared minus 4ac, if this is 0, then we have 0 divided by something, it's still 0. So in that case, x is only equal to one value, and that you have a parabola that actually touches the x-axis in one spot, and we only have one little root there. That root is equal to the negative b over 2a. Okay, so when the b squared, they call this the discriminant, b squared minus 4ac. When this equals 0, we only get one root. We only get one value that satisfies y equals 0, and that's where it touches. If b squared minus 4ac is greater than 0, then we can, if b squared minus 4, then we have a radical of a number. Let's say it's 1. So the square root of 1 is 1, and we have 1 divided by 2a. So we have this point of symmetry, and we do plus 1 divided by 2a, and then minus 1 divided by 2a, and we get 2 real roots. And this is actually 1 real root and 2 real roots. Where it goes imaginary is when this is negative. When the square root of something returns a negative, when b squared minus 4ac is a negative value, then you're trying to take the square root of a negative, and your calculator gives you that error term. Right, so if I grab my calculator here and I put in, let's just say we get 1 and hit the negative sign, and then I hit the square root button, I get an error. In mathematics, it's more than just this error, it's called an imaginary number. But when b squared minus 4ac is less than 0, we get 2 imaginary roots. Because it generates a value, so we still have this plus and minus, so there are 2 different ones. So our options are 1 real root, where it touches the x-axis. When this term b squared minus 4ac is 0, this whole part goes to 0, and we only have x equals the negative b over 2a, and we get that location where the vertex is right on the x-axis. When b squared minus 4ac is less than 0, then the parabola is not right on the x-axis, and it's either below it and it crosses it, or it's above it and it crosses it the other way, and we get 2 real roots, 2 real values, x equals 2 and x equals 7, or whatever the numbers are. And then we have a situation where we've got a parabola, but it actually never crosses the x-axis. This is the case where we're taking the square root when that discriminant, b squared minus 4ac, when that's a negative value, then we're trying to take the square root of a negative, and that doesn't work. But that's the situation where we don't ever get a real root that actually crosses the x-axis. Okay, so the discriminant is a new term we're talking about, and that's b squared minus 4ac. And again, that gives us that amount of differential from the vertex. And then the vertex is an extremely important piece. We calculate that vertex at x equals negative b over 2a, and then the actual y value that's associated with that, we plug that back into the original function. Wherever you see x, put in negative b over 2a. So in this case, our b value is what? 18. So we got x equals negative b, so negative 18, divided by 2 times a, which is 1. So that's negative 18 divided by 2. So at x equal to negative 9, that's our location of our vertex. And then f, if we apply that function, f of negative 9, we'll be able to get the y value. So let's actually plug that in just for a moment. We got, right, so we have x squared plus 18x plus 4. Now it's not equal to 0 here, that's equal to, this is my function of x. So we're actually plugging in the negative 9 value, or the negative b over 2a, to determine what is the y value of this function evaluated at that point. So we're applying f of negative 9 here. So we have negative 9 squared plus 18 times negative 9 plus 4 is equal to the function evaluated at negative 9, which is the y value. So we have negative 9 squared, negative 9 times negative 9 is positive 81, plus 18 times negative 9, 18 times 9 negative equals negative 162, plus 4 is equal to my y value. So I get 162 negative plus an 81 positive plus 4 equals negative 77. So y equals negative 77. So this point over here is -9, comma, -77. Okay, and then we're going to find those two locations by solving the quadratic formula to find out where it actually crosses the x-axis as we come up. All right, so that's page 1. And then page 2, let's actually solve that. So let's use the quadratic formula again. So now I ran out of paper here. So we have x equals -b plus or minus b squared minus 4ac over 2a. And I kind of take a lot of paper when I solve these problems. I don't know why, but x equals the -b, so b we determined was the multiplier times the x. The b value is 18. So I have -b, -18, plus or minus the square root of b squared. So b is 18 squared. 18 times 18 minus 4. The a value is a 1, and the c value is also 4. So minus 4 times 1 times 4. -4ac over 2 times the a value, which is 1. Right, we had a equal 1, b equal 18, and c equal to 4. And again, we have a parabola opening upward because the a value is 1. And we already showed that. We knew that it was we showed that the, did we show that? We didn't actually calculate this. We talked about it to show that b squared minus 4ac was, or these are our three options. Either b squared minus 4ac is equal to 0, and we get one root, or b squared minus 4ac is greater than 0, and we get two roots. And this is what I suspect we're going to have right now. But let's try it out. So b squared minus 4ac is what we're calculating right here underneath the radical. So we have 18 times 18 is 324. I'm just going to write that right there, 324, minus 4 times 4 is 16. Okay, so I got 324 minus 16 equals 308. So I have x equals -18 plus or minus the square root of 308 divided by 2. Okay, so b squared minus 4ac is positive. That means we have two real roots, because we can actually take the square root of 308 and get 17.54, and then we get -18 plus 7.54 divided by 2, and -18 minus 7.54 divided by 2 to find our two roots. It depends what the problem's asking for. If they ask for an exact solution, they want you to simplify the radical. So when we simplify the radical, we have to look for numbers to pull out. And 308 doesn't look like a perfect square to me, but maybe it's divisible by 4, which is a number 2 times 2. 4 times something might be equal to 308. Okay, but let's do two things. Let's do two things here. So first thing we're going to do is just find out these real values, and then so there's two ways of doing this. We could look for the exact solution, or we can just calculate the value. You know, Professor Lair likes the value, but the math department and the mathematicians in the world like the exact value. Although, anyway, I don't want to go there. -18 plus or minus, so what was the square root of 308? 308 shift square root is 17.55 divided by 2 times a, and again a was 1, so that's just divided by 2. And so we have two values here. We have -18 plus 17.55 divided by 2. And that's that situation here. We got the negative b over 2a plus that value. So what do we have here? We have that value already there, and then we're going to add a 18 negative to it. So I had 18 plus that equals 0.45, and I divide that by 2, and I get x equals this. So x equals negative 0.225. And then we also have negative 18 minus 17.55 divided by 2. So that's 18 negative minus 17.55 is negative 35.55 divided by 2 equals negative 17.775. So these are the two locations that cross where y is equal to 0. So if we look back over here on our plot, this value over here is negative 17.775, and the x value over here is negative 0.225. So with the plus and the minus, right, we got a minus 9 here, which, look at it, right? It totally makes sense. We got minus 9 here in the middle. We got minus almost 0 and minus almost 18. 18 divided by 2 is negative 9. Or if you add these two numbers up, it's probably going to be equal to negative 18, because that value is definitely minus 9. Right? So it's negative 17.775 plus 0.225 negative is indeed 18, and 18 divided by 2 is negative 9. And that shows this line of symmetry. So when they ask you to plot it, you solve for these locations where y equals 0, and we use the quadratic formula. You could factor it, but a lot of times factoring doesn't work, but the quadratic formula always works. Well, always works depends on, we have 3 possibilities. There's always 3 possible outcomes. We're either going to get 1 root. If that value is 0, we get 2 positive roots. This is the most common, that's why I have a star here. We almost always get 2 roots. But that's not, that's not always the case, but that's, in general, that's the type of problems we're solving. And then there are situations where that discriminant is negative and we have an imaginary root, and that's the case where it just never gets down to, or never gets up to, the x-axis. Okay, but in this case we had 2 real roots. There they were. We had that line of symmetry, which we just proved, and then we evaluated that point to be negative 9, negative 77. And we could plug this into, like Desmos, plug that in, and then plot it and see what you're going to get the same thing. Okay, so we found our x locations, and again, these are literally the points that satisfy where y equals 0. So you have the point you have the point 0.225 negative for the x value, and the y value is 0. And then we have the other location, the other point, we got negative 17.775 comma 0. So these are our 2 locations that they're called roots, or the solutions to the problem, right? When you did factoring and then we set them equal to 0 and then you solve for what the x values were. That's roots, or we use the quadratic formula and obtain the roots this way. And then the other point we calculated was the vertex, which we also know is at negative 9 comma negative 77, right? And we showed that the a value was positive, and we had a parabola opening upward. And even if we didn't have this parabola yet, right, we had 2 points and a point below it, well then it has to open upward, because it's got to go through all these points. Okay, so that whenever you see it, the a value is positive, then the parabola opens upward. When a is positive, parabola opens upward. Right? And then we have the vertex occurs at negative b over 2a, right? And we have our quadratic formula, we have our formula, we figure out a, b, and c, and the vertex's x value is this, and the y value is the original function. No longer equals 0, it equals whatever, we're going to figure out what the y value is. So we evaluate the original function with x equal to negative b over 2a. Right, and then we evaluated that original function. Here I evaluated that original function. Right, we solved for, we did it up here actually. So we looked for the x vertex was negative b over 2a. We plugged in the negative b over 2a, we get this negative 9. Right, so from negative b over 2a, from x equal to negative b, where x equals to negative 9, we're going to find the y value of that function. So we're going to evaluate f of negative 9 to get the y value. And now we have the vertex in the two roots. Okay, and then lastly was the exact solution. So when we have 308, now I'm going to cheat and know that they want us to get rid of this 2 here. So there's probably a 2, so something times 4 is equal to 308. I kind of already know that by the hint that they gave us. Okay, so it's 77. So this is x equals minus 18 plus or minus, you could do 4 times 77 over 2. And when you have a number that's a square, you can pull it out of the radical. So this becomes 2 times the square root of 77, right? Because if we take 77 square root times 2 equals that 17.55 number that we had earlier. So we're just going to pull, but this is an exact solution, so we're going to pull that out. So you have x equals minus 18 plus or minus 2 times the square root of 77, all over 2. And again, this is like saying 18, this is equal to negative 18 divided by 2 plus and minus 2 times the square root of 77 over 2. So we can simplify this to get x equals minus 9 plus 2, nope, not 2 because we canceled that 2 out, just times the square root of 77. So that's the one root, and then your other root is x equals minus 9 minus the square root of 77. And that assumes that the square root of 77 is as simple as we can get. And the only factors that I know of 77 are 11 and 7, neither of which are perfect squares, so we can't pull it out of the radical. And that's our answer. All right, so then that's kind of how you solve all these. You put them into standard form, you get your equation, put in the standard form, you look to factor. I hardly even factor anymore. I always go straight to the quadratic formula. I know it takes a little bit of time and work, but it always works. So if you don't see the factors right away and they ask you to factor, you could always plug in the quadratic equation and get your answers. Just remember though, they are the answers already solved. These are the actual x values. X equals these values. So when you factor, these are going to be the negative of these, because you remember you got to bring the other side, you got to bring the value over, and they end up being the negative of whatever's in here when you solve for x. So the quadratic formula is going to be given to you already in the proper number format, and those values, we're doing that to find where the parabola crosses a value. And then later on, when you're doing more complicated math, it doesn't always have to be equal to 0. You can set it equal to another place and find the place where it equals 1. So if you wanted the numbers where x, what are the x values when this is equal to 1, bring everything over here and then set it equal to 1. And then these would be the two values that the quadratic formula evaluates at. Okay, so that's it for this one, and you guys should be working on the problems in the text. Make sure you read the announcement for today on 11.4. look back over the announcement on 11.2 they gave you, and you should be able to solve about the first 20 problems in homework 4. Okay, have a great day.